the notes, the heading you're going to give it is rectilinear motion. Ooh, that's a big R.
Is that one word or two words?
Rectilinear is one word, even though I put a space in there. As in like up, down, left, right, like rectangle. Rectangular, the rectangular plane is the XY plane. So that's what they mean by like we're moving around on the XY plane. Particle motion, like you can see on your resource page, that blue sheet. Another word for it, particles moving. These are very, very common on the AP exam, these types of questions, okay? So the blue sheet is kind of a cheat sheet so that when they say specific key phrases, you know exactly what they're talking about. But we're gonna go ahead and go over that now, all right? So in rectilinear motion, you have an object that travels in a line. They will often say that the object is traveling on the x-axis back and forth, or it's traveling on the y-axis back and forth. No, this would be instead of homework tonight. So we're starting it, we're gonna see how far we get. We're starting it because you need it to do the last 3 questions on the book problems. All right, S of t gives the coordinates of the point. And we typically call the point P. I don't know why they use an S. So S stands for the position, the original position of the point. Yeah, emphasis on the S. The velocity of P is V of t, which is the first derivative. So S prime of t is the same thing as V of t. They do not call it S prime of t, they always call it V of t. And when you see that in your head, you'll think, oh, first derivative. Mm-hmm. The speed of P is the absolute value of the velocity, because velocity, if you remember from physics, can have a positive direction or a negative direction. You can say that you're going backwards. So when we talk about velocity, we're going to have signs, positive and negative. When we talk about speed or how fast something's moving, then we say just the absolute value of velocity, okay? So if you can, but with velocity you could. So if you had a negative velocity and you're on the x-axis, then that would mean you're moving left. If you have a positive velocity on the x-axis, you're moving to the right, all right? Or if you're on the y-axis, negative would mean you were moving down. Positive would mean you're moving up. So velocity being positive or negative makes sense. Speed being positive or negative does not make sense, okay? So velocity tells you how fast, but it tells you the direction it's going. Speed does not. Speed just says how fast, okay? Acceleration of P is A of t, which is the first derivative of the velocity, which is the second derivative of the position. So in your head, whenever you see A of t, you're going to be like, oh, that's the second derivative. Yes. You will eventually do so many of these problems, these will become the easy ones. You get to something that doesn't make sense. Like concrete wise, it would be abstract. It would, like, mathematically you could find it, but in your head you can't make sense of it. Yeah. All right. If the particle is speeding up, you will see that the velocity and the acceleration have the same sign. So they're either both positive or both negative. So if your velocity was negative and your acceleration was negative, that would mean that you were like slowing down in a negative direction. The minus with the acceleration, the minus with the velocity would like cancel out, and it would make the particle appear to be speeding up, basically. Or if you're saying you're accelerating and velocity is positive, then of course that would be speeding up. So when we say speeding up or slowing down, we do not use that to describe acceleration because that's different, okay? So if you want to know if the particle is speeding up, you check the velocity and the acceleration at that time and you see if they have the same sign or if they don't, all right? So a particle would appear to be slowing down if the velocity and the acceleration have opposite signs. So when we are talking about something speeding up and something slowing down, we are not talking about acceleration. That's totally different. Acceleration is the second derivative. Speeding up and slowing down, we're talking about the first derivative and the second derivative at the same time and saying what's happening with them. Okay? Yes?
Does that mean that all of them have to have the opposite signs?
Yes, that would be, you would look at it for like at a specific time. So you'd say at 4 seconds, is it speeding up or slowing down? You'd plug in 4 to both the first derivative and the second derivative and see what the signs are. So you would check it for an exact moment in time. You would not say it's always slowing down or it's always speeding up. You would check it for a specific instance. Yeah. All right, so here's our example. We are going to take the original function that describes the position of the point, and that original function is t to the third minus 12t squared plus 36t minus 20. And we're going to use that function and we're going to describe the motion of the point. Describe the motion of P on the interval from -1 to 9. So we're saying starting at -1 seconds, yes, I know that's weird. Starting at -1 seconds going to 9 seconds, describe the motion of the particle.
I'm trying to figure out a mathematical way to say you have the same sign. And I think x over absolute value of x is equal to y over absolute value of y would be a way to say they have the same sign, right?
You can make that as complicated as you want, but I'm going to leave it like this. All right, so S of t, I'm going to go ahead and just copy this down. I want to have all three of these written right next to each other. So V of t would be what? 3t squared okay, and then A of t, okay. So if we want to see when the particle is not moving, because it could move right, it could move left, it's going to stop moving for a moment when it switches directions, right? Because you can't you have to like stop, then switch. So what we want to do is we want to see when the particle is not moving. Which of these three do you think you would look at to see when the particle is not moving? Yeah.
Velocity.
Velocity, and what would you want it to equal? 0. Okay, so we're going to say V of t equals 0 when the particle is not moving. And so I'm going to take that 3t squared minus 24t plus 36, and I'm going to set it equal to 0 to see when the particle is not moving. Okay, so how do I solve that? Take a GCF of 3 out. So we're looking for two numbers that multiply to 12, but add to -8. Okay, so 3t minus 6, t minus 2. Okay. So what are the two time periods, or the two moments in time where the point is not moving? Okay, 2 and 6. All right, so what we do is we draw a number line, -1 to 9, and we put 2 on the number line, and we put 6 on the number line. It's supposed to end at 11:06. Sorry. Must be. All right.